Okay, well, I'm back. This is Mr. McAllen again, and we are on the last stretch of the final exam review. This is the open-ended, and this is the third page, I believe, or the second page. I've lost track, but we're on number 9. So let's start with number 9, and we will work on solving this linear equation. You have 6 times 3x minus 1 equals 24. Excuse me, and we can just divide out the 6 if you like, and that would give you 3x minus 1 equals 4. And now 3x is equal to 5, or x will equal 5/3. So that's our first one. Solve the exponential equation. We have 4, number 10. 4 to the 9 minus 3x equals 64. Switch everything to base 4, so I don't have to do anything to the left side, but I do have to change it to 4 raised to the third up for the right. Now I just set the bases, or the exponents, equal. So now when I solve, I have negative 3x is equal to negative 6, or x will equal 2. It's always good to take that value, plug it back into the original, and when you have 4 to the 9 minus 3 times 2, that gives you 4 to the third power, which is 64. So that answer checks out. The next one is a logarithmic equation, and in this case we just rewrite as exponential. So we'll take 16 raised to the 1/2 power equals x, and everybody should know by now that a half power is just a square root. So x is equal to the square root of 16, which is 4. On the next problem, I'm just going to write it down here in the space below. For number 12, we have common log. That's what happens when you don't have a base written. You consider it to be a common log. X plus 10 minus common log of x plus 4 equals common log of x. We have to compress the logarithms on the left. That becomes a 1 common logarithm of x plus 10 divided by x plus 4. That equals a common log of x. We can now just drop the logarithms and set the function inner values equal. Cross multiply. And solve like a quadratic. And now I'm just going to combine like terms and hope that this is factorable. And it is. And that yields 2 answers. X equals negative 5 and x equals 2. Now here's the thing. You need to make sure that when you plug in your answers that they work. And logarithms will work as long as you do not have a negative number inside of the logarithm. So the first one, if I try negative 5, that will result in me using log of 5 minus log of negative 1, and that can't be. So the negative 5 unfortunately is going to have to be crossed out as a solution, but the second solution, x equals 2, will work, because when you plug 2 in, you will not get a negative number. So we are now going to, well, now I'm just going to pause and clean up the writing area, so I'll be back in a minute. Now we're working with number 13, and 13 is asking for us to describe the position relative to 2 to the x. Well, 2 to the x has a few points on it. That it has an asymptote at 0. It has some points at negative 1 comma 1/2. It has a point at 0 comma 1 and a point at 1 comma 2. When we consider how this function changes the parent function, this function would be in a description would be down 4 and moved right 3. There would be no flips because there are no negatives. Where on our next graph we have the function 4 to the x, which has the 3 basic points of negative 1 comma 1/4, 0 comma 1, and 1 comma 4. And relative to that graph, this graph will move. It will be flipped over the x-axis, and it will move right 1 unit, because this is because of the negative in front of 4 to the x, and this moves right 1 because when you take x minus 1 and set that equal to 0, you get it to be solve for x equals 1, which means the whole function moves to the right by 1. The last function, the last problem of the whole review, is a log function. And if you want to plot a log function, you can either well, since we didn't go over this, you can use your calculator to plot this. So I'm going to bring up the calculator and show you how you do that. Okay, well, what I have here is the graphing calculator, and I'm going to just hide the all the other parts of the view. And when I move the calculator over here, what we see is we're going to be plotting log base 2 of x. So under the calculator, on the menu button, on the math button, if you just arrow up a few times, you'll see that you have this choice called log base. And what that allows you to do is you can now plot a log base 2 function. So I put 2 there, and then if I put a x, I can plot that function and see what it looks like. And you can see here it looks like an exponential function, kind of. It looks like an exponential function if you kind of tilt the graph. And if you want, you know that since log base 2 of x, that is the inverse of 2 to the x, we can see that it has that symmetry property that we talked about across the line y equals x. So let me graph that along with it. So I'm going to graph 2 to the x, and you should see the symmetry that we talked about when we plot that. And here comes the exponential, and as you can see, there's a symmetry about y equals x. So we basically have a function that has an intercept at 1, and the basic sketch would look like this, where we have an asymptote. Now this function here, because of the x plus 6, we have a movement to the left by 6 units. So then we just move that asymptote to the left, and we redraw that exponential, that logarithmic function, and you can graph that if you like on the graphing calculator. And I'll just change this function to x minus 6 or plus 6. And my window's too small. Let me make my window a little bit bigger. So we have that function in the window space. And I would just enlarge my minimum x value to -10. And there you can see the base 2 logarithm, and on top of it still is the graph of 2 to the x. Hopefully this has been helpful, and if you have any questions, we can definitely talk about it tomorrow in class. So good luck, and write down your questions so that we can talk later. Take care.